All right, my friends, let's see how you did. So hopefully it makes sense. The idea is to add up infinitely many, infinitely thin little rubber bands, essentially. And so if we can find the formula for one of them, then all we'd have to do is pop that formula into an integral. And so I hope it makes sense that we would basically be adding up a whole bunch of 2 pi r s's, where s would be the appropriate arc length formula. Okay, so 2 pi could be factored in front of your integral, and then you'd have the integral from, it looks like we want to start adding at c and stop adding at d. Please make sure you always scan your appropriate axis from negative to positive. So for x, that means from left to right, and then from y, that means from bottom to top. Okay, and then I'm always going to use the word radius for that part. That way, if it's not just your function rule, you'll know to look at what the radius is. And then the appropriate arc length formula here, since this would be a dy integral, you're accumulating these rubber bands as you scan the y-axis. You'd make sure that you put the arc length formula in that would be in terms of y, which would simply be 1 plus f prime of y squared, and then with respect to y. There we go. And so this would be for rotating about a vertical axis. There we go. And then what would make sense for the radius if you are rotating this about the y-axis? So I'm hoping it's a matter of looking at the picture. Okay, pictures are the most empowering thing that you can have. And so, so in this case, if you're rotating about the y-axis, I hope it makes sense. The radius of one of these little rubber bands would be the x-coordinate, but you'd need to know what the x-coordinate is in terms of y, so that would simply be f of y. But I don't want to put that in the formula, like I mentioned before, because if the axis of symmetry was, way over at, x equals negative 11, then the radius would be f of y plus 11 more units, or if the radius was way over at, x equals, 20, then the radius would be 20 units, take away f of y. So I think we're kind of better off with just the word radius there. There we go. All right, my friends, take a moment and memorize these if you don't have them memorized already, even if you need to pause the video, and then go ahead and see how example 2 treats you. So set up and evaluate the definite integral for the area of the surface generated by revolving the curve y equals 2 times the square root of x on the interval from 4 to 9 about, for part A, the line x equals negative 2, and then for part B, the line y equals 7. So once you have a clear integral setup, go ahead and make your calculator do the rest of the work, remembering to write your answer in terms of pi, and then where you multiply in and have your answer just in terms of a decimal. All right, best of luck. See how it goes.